We'll get started here. Last day, very exciting. This is the last short little announcements. 17.1 is due tonight and 17.2 is due Monday. That way, all the content done before all of my students take their exams. Their final, which is really, it's not cumulative, it's just online. Question? On Monday? It's finals week. So unless you have a final for one of your classes, you won't be meeting. The only time that you will see me next week is either if you want to meet, if you have questions, I will set aside time. Like I'm not gonna just be here for drop-in hours because what ends up happening is I end up sitting somewhere just doing my own work, and I'd rather do my own work at home with my dog. But if you're like, I have questions, I want to go over stuff, just email me. I've got a lot of flexibility and I'd be more than happy to get together. Otherwise, our class is scheduled to do our final exam on Thursday, from 8 to 10. It'll be in this classroom. That's when your take-home portion of the exam will be due. And then you'll take the exam. It's just on linear math, but Monday, like we don't meet for class anymore. Okay, so our only meeting is for our third exam next week. As before, you get a page of notes, get a calculator. And just again, let me know if like this doesn't work. That's why I've listed my other exam time. And if neither of those work or you sleep through your alarm or something, just reach out as soon as possible so we can make sure that you get that final exam in. The lines handout. Yeah, I'm okay if you want to bring that little line handout as a little cheat sheet. Just please don't have a bunch of notes all over it. That's probably more than enough. But rather than, I mean, the reason I made that is so that students could have a little cheat sheet. Yes. Yeah, just again, don't if you have notes all over the lines handout, then I'm probably not going to let you use a page of notes just for, I don't want anyone to have an advantage or, be going above the gift of a page of notes. All right, so we ready to do a linear programming problem, start to finish? That's all we've got. Once we make it through this whole problem, we'll call it a day. Call it a term, really. So here is the statement of the problem. It's going to look very identical to what you'll be doing on your take-home exam. So really good to kind of be following these steps. Maybe rewatch this video if you get confused at any point while you're doing your take-home exam or take-home portion of the exam. But again, students tended to be very successful. And I really liked being able to ask students to do a full linear programming problem start to finish. So I think it's a cool opportunity. And then it's like going into the actual exam, you can maybe feel good about at least 20 of the points for the exam, you feel really confident on. All right, so here's the problem that we're going to answer. There is a factory that makes chairs and tables. They sell the chairs, bless you, for $200 each, and the tables for $600 each. Chairs take 6 hours to make and require 3. I didn't know what a unit of wood would be, and so my morning class we came up with bushels. So we're using bushels, 3 bushels of wood. I don't know if that's actually how you would measure an amount of wood, but bundle. I'll write bundle. It doesn't really matter. My notes say orders of wood. I wanted to say pallets of wood. I didn't know how to spell pallets, and my morning class said bushel. So I was like, all right, we'll use bushels. We'll use, what did we say, bundles? These are big bundles of wood, right? It requires 3 bundles of wood. It is fun to say bundle. uh, what? Bundling your home and auto. Yeah, where's Josh from State Farm? Requires 3 bundles of wood. Okay, and tables take 12 hours to make and require 10 bundles of wood. Yeah, now I'm thinking about there's that one commercial where he's like, we just have one word, home and auto insurance or something. And then he's like, that's 3 words. And he's like, not if you bundle them. And that's what I'm thinking of now. Dumb insurance commercials. Yeah, it's true. It's very true. Good marketing. Does anyone remember the Quiznos commercials from the 90s? I don't know if y'all are old enough. Google Quiznos commercial. I had like a hamster. It was like a floating hamster with like big bug eyes and these like mouths that they would animate. And it would like sing a song. It was like, we love the subs, the Quiznos subs. And it was like the most bizarre thing that you can imagine. It was like some like Quiznos corporate spent probably millions of dollars making this commercial, and it just still blows my mind because it was like on TV for a while. I think they made 2 iterations of this ridiculous commercial, and I just always remember. No. Yes, it ran for a while, and you can definitely find it online. Maybe after class, if we still have time, I'll stop the recording and just play it so we can all enjoy the ridiculousness of marketing from the 90s. Requires 10 bundles of wood. Okay. The factory has 300 bundles of wood available and 480 operational hours. To use. To maximize their revenue, how many tables and chairs should they make? All right, so here's our problem, start to finish. And the first thing we're going to do is define our variables, right? What are the quantities that we want to play around with? We start here because even our objective function will require the use of our variables. So the first step is going to be define the variables you will be using. And I want to make a note, it was only a half point, but when we're defining variables, I want us to be a little bit more specific than just saying like C is chairs, T is tables. I want us to say specifically what it is, and it's the number of chairs, the number of tables. Because it's possible that we could have a question where maybe we don't know what the cost of the tables is, right? And so then we're looking for a different attribute. So it seems like a small thing, but I'm putting points on these types of questions. And if you just are saying C is chairs, T is tables, to me, it's like, well, why is that worth 2 points, right? Let's at least be more specific. So if you want to use X and Y, by all means, you can. I like to use letters that help me remember what my variables represent. So I'm going to say, let C equal the number of chairs made. And I'm going to let T equal the number of tables made, right? This comes from our question, how many tables and chairs should they make, right? Therefore, I know that my solution should answer that question. My variables are going to be the answer to that question. Okay, perfect. I just want to make sure. Okay. All right, so we've got our variables. We okay on this page? Step 2, define our objective function. Step 2, right, we have our variables. We know what quantities we're playing around with. Step 2 is define your objective function. What's our ultimate goal? It's to maximize our profit. That's our end goal. We don't care if we use all of our resources. What we care about is that we maximize our revenue. So just a little note, I'm going to underline this in red. When I go back to the statement of the problem, I'm going to underline everything that deals with my objective function. Right? I really like to organize my information. Right? The question that we're being asked is maximize our revenue. So there's my objective function, maximize our revenue. And the information that deals with revenue is that we sell the chairs for $200 each, and we sell the tables for $600 each. Right? There's everything that has to do with the revenue coming in for this factory. Right? So that gives us the objective function. Our objective function is going to be maximize our revenue, which is going to be 200C. We get $200 for each chair plus 600T. If you want to write is equal to R, that's great. If you don't want to, I'm okay with that. I don't think we need to define an extra variable as long as we know that this quantity is the value we're trying to maximize. If you want to give it another variable name, that's fine. I won't mark you down if you don't have it. Right? Really, the quantities that we're most concerned with are C and T. So we have our objective function. We want to maximize our revenue, but we also know that there are real world constraints. We can't just make an infinite number of chairs and an infinite number of tables. So we are going to now write out the real world constraints. Define the constraints of this problem. And another hint, there will be 4 constraints. I have 2 unknowns. So we're going to have 2 constraints, one dealing with the total amount of wood that we have and one dealing with the total amount of time that we have. And then we have our additional real world constraints that we can't make negative tables, we can't make negative chairs. All right, so one of our constraints is how much wood we have available. I'm going to go back to the statement of the problem and again group everything based on this constraint. How much wood we have. Right? The factory has 300 bundles available. So there's my total. We know that chairs require 3 bundles of wood. So there's my information about chairs. And then tables require 10 bundles of wood. Right, so everything in green that I've underlined deals with the amount of wood that's available. We have up to 300, 3 for a chair, 10 for a table. So my first constraint is that 3 bundles times each chair plus 10 bundles for each table needs to be less than or equal to the 300 total bundles of wood that we have available. The other constraint that we have is the amount of time or hours available to us. I'm going to do this one in blue. So again, we'll go back to the statement of the problem and try and organize the information. Well, chairs take 6 hours to make. Tables take 12 hours to make. And we have 480 operational hours that we can use. Right, so everything in blue, and I'll apologize, this was also in blue, but everything in blue up here deals with the amount of time that we have available. And so our constraint for time is that 6C, because we have 6 hours per chair times the number of chairs, plus 12T, 12 hours per table times the number of tables, is less than or equal to the 480 potential available hours that we have. And our final two constraints is simply that I can't make negative chairs and I can't make negative tables. Don't forget these, they're very important. There's not really work to be shown on these ones. It just keeps us in that top right quadrant, in quadrant 1 of our Cartesian coordinate system. Right, we're not going to go into the negatives in X or Y direction. Another thing to note, I'm going to let C represent my X value and T represent my Y value. And I'm going to try and make sure that I'm consistent throughout the statement of the problem. When I change my variables to not being X and Y, it's really easy to accidentally mix them up. But if you do that, we can get an incorrect solution. So I'm going to have C as X, T as Y, keep things in alphabetical order. So step 4, I have my real world constraints. What we're going to do is now graph these constraints to find the feasibility region, right? How many tables and chairs can we make pushing up against the limits of our constraints? Right, so we will graph our constraints to find the feasibility region. Right, step 4 is a little bit involved. I think on your take home, I might even break it into a couple steps. I prefer to find all of the information and then do the graphing at once. If you want to find the intercepts and then graph, and then find the intercepts of the other one and then graph, that's perfectly fine with me. Right? Just the way that I tend to do it is find all the information and then do all the graphing at once. So first thing we are going to do to graph our constraints is we're going to pretend that this is equality and then find a test point and shade towards or away from that test point. So I'm going to use green again, and we're going to find the intercepts of the line 3C plus 10T is equal to 300. To find the intercepts, we'll let C and T be equal to 0. So first, let's let C be equal to 0. And then that tells me if C is equal to 0, that 10T is equal to 300. So that term disappears. I divide by 10, and I get T is equal to 30. So my first coordinate point is 0, 30. Just a note, again, I'm putting my C value first and my T value second. I want to be consistent, or we could make a mistake. So there's one of my intercepts. There's my T intercept. Let's find our C intercept by letting T be equal to 0, which tells me 3C is equal to 300, because this term disappears. Divide both sides by 3, and you get C is equal to 100. So my second coordinate point is 100, 0. Here's my C value, there's my T value. Finally, this is now graphing the line. We now need to know which side of the line are we going to shade in. So we're going to pick a test point. And I like to pick the test point 0, 0, because it's the easiest one. And we plug it back into our original inequality. So is 3 times 0 plus 10 times 0 less than or equal to 300. This is all 0. That's what's nice about picking 0, 0. Is 0 less than 300? Yes, this is true. So we will shade towards 0, 0. Now we're going to draw our line, and then we're going to shade in the direction of 0, 0. All right, so here's everything I need for my wood constraint. Questions so far? We all right on this part? Yeah. Okay. So we're going to now do the same for the constraint of the amount of time we have. How many operational hours? So we start by assuming we have equality. So 6C plus 12T is equal to 480. And just like above, we're going to find the intercepts by letting C equal to 0 and letting T equal to 0. If C is equal to 0, that tells me that 12T is equal to 480. Divide by 12 on both sides, and we'll get T is equal to 40. Okay, so for this blue line, our first intercept is at 0, 40. Right? C is 0, T is 40. We're going to do the same thing now, but we're going to let T be equal to 0, figure out where that C intercept is. If T is equal to 0, then that means 6C is equal to 480. Divide by 6, and we get C is equal to 80. So my next coordinate point is 80, 0. One thing to note, on your take-home exam, I have provided you with coordinates when you're actually graphing these inequalities, and the coordinates have a large enough scale that you can graph the intercepts. There might be some questions on your homework where if you find the intercept, it might happen at like 0, 15, and that will be off the coordinates that are given to you. So you'll have to find a different coordinate point within the region to graph that line. But this is the general approach that I want us to take. We're just sometimes limited by the coordinate system that has been provided on the homework. But know that if you are doing the take-home portion of the exam and you get an answer that is off the coordinates, you probably made a mistake. All right, so lastly, we want to find our test point. Which side are we shading towards? And once again, the easiest test point is simply 0, 0. Plug 0, 0 into our original inequality and see if it's true or not. 6 times 0 plus 12 times 0 less than or equal to 480. Is 0 less than or equal to 480? Yes, this is true. So we will shade towards. Again, we'll shade towards 0, 0. Questions on this part? Feeling all right? Ready to do the actual graphing? I think on my take-home portion, there's a step that says find all the intercepts and the test points, and then the next one is graph, but I just called this one for now, graphing our constraints. So again, this is not going to be to scale because I don't have official coordinate system here, but I'm going to try and at least have straight lines so that the image looks okay. I'm going to say this is my C axis. This is my T axis. Please don't forget to label them so that, again, you're staying consistent with how you're answering the question. Just a reminder that in green, I'm graphing the inequality 3C plus 10T less than or equal to 300. And in blue, I'm graphing the inequality 6C plus 12T less than or equal to 480. So the values I need, and not to scale, but here's 30, here's 40. We'll say this is 80, this is 100. My green intercepts were 0, 30. So here is my T intercept of my green line. kind of hard to see the color of it. That's green. And my other intercept was 100, 0. So there's my other coordinate point. And I'm gonna connect them with a nice straight line here. Right, and of course we said we're shading towards 0, 0, so we're going to shade below this line. All right, again, I only drew the top quadrant because X has to be bigger than 0 and Y has to be bigger than 0. You don't really have work to be shown, just make sure you know that we're butting up against these two axes and never going below them. So my blue line had intercepts at 0, 40. So here's 0, 40. And then it had another intercept at 80, 0. So there's my other coordinate point. And again, I'm going to use a straight edge to graph or to draw in my straight line.
Run a trick to draw a straight line, just look at what you're drawing, it should automatically.
That's usually what I do. I just want to demonstrate like using a straight edge, but oftentimes I've drawn in it and it does turn out pretty nice, but since I'm trying to model like the proper way, exactly, yeah. But in general, like as long as your lines aren't like very obviously curved, I'm not gonna take points off, but do take it, somewhat seriously. And again, we are shading towards 0, 0, which is right here. So we're shading below this blue line. All right, so hopefully we can see that of the 4 regions, this triangle doesn't satisfy the green line. This triangle doesn't satisfy the blue. This doesn't satisfy either of them. But within this region here, it satisfies all of our inequalities. This is our feasibility region that I'm shading in red right now. So the great thing about the feasibility region is I need to find the test points. What are the extreme corners of my feasibility region? And we already have 3 of them. There's no work to be shown for these 3 corners. We already essentially did that. Here is 0, 30. Here is 80, 0. Here's 0, 0. But we will need to use the elimination method to solve for this corner. When you're doing your online homework, if you want to graph and use Desmos to find those intersections, great. On your take-home exam, use the elimination method. You're explicitly asked to do that because I want to make sure that we can use that skill as well. All right, so our next step, step 5, is let's solve for the missing corner. Right, that corner happens where the blue line 6c plus 12t equals 480 and 3c plus 10t is equal to 300. Right, the lines are where we have equality. So the system of equations we're solving is 3c plus 10t is equal to 300 and 6c plus 12t is equal to 480. We're going to use the elimination method here. The easiest variable to eliminate is going to be the c's in my mind. So I can turn this 3 into a -6 pretty easily, more easily than I can turn a 10 and a 12 into a least common multiple. So I'm going to multiply this top equation by -2. I'll rewrite my equations right below. -6c minus 20t is equal to -600. And my bottom equation doesn't change at all. 6c plus 12t is equal to 480. We add our equations. We get -8t. The c's cancel out. -20 plus 12 is -8. -60 plus 480 is -120. When you divide by -8, I get t is equal to +15. Negative over a negative is +15. Right, this should be somewhere in between 0 and 30. So at least Right, that seems reasonable. We're gonna plug t back into our favorite equation here. I like the original of this top equation because multiplying by 10 is kind of nice. So 3c plus 10 times 15 is equal to 300. And now I solve for c. 3c plus 150 is equal to 300. I'm going to subtract 150 from both sides. 3c is equal to 150. Divide by 3 and we get c is equal to 50. So my missing corner has the coordinates 50, 15. And this is a really easy place to accidentally mix up your variables because I solved for t first, but it still corresponds to my y value. C still corresponds to my x. So I need to make sure that I plug in 50 for C and 15 for T. Right? But now we have all of our corners. We have 0, 0, 0, 30, 80, 0, and 50, 15. Okay, so essentially our last step before we answer the question is let's plug in all of these coordinates into our objective function and see which one gives us the maximum revenue. Okay, so step 6, plug in all the test points, aka the corners of our feasibility region, into the objective function. Right, our objective function again was 200c plus 600t. And our test points, and we'll actually do the plugging in on the back side, but the test points are 0, 0, 0, 30, 80, 0, and 50, 15. Yeah.
Do we have to do the plugin step on 6?
Yes. Yes. Yes, it might be obvious that 0, 0 is not going to give us our maximum, but I still want us to practice test plugging all of our test points in. Again, our objective function is to find the maximum, but there are examples where we might be looking for a minimum. We might have some sort of like cost and we're trying to minimize our own cost. This example isn't that way, but just, you know, it's a pretty quick calculation. So I do want to see the work for all 4 of them. Again, it won't take long. We'll do this whole thing in like, I mean, we'll be done in 3 minutes, I bet. We okay on this page? Yeah. All right, so here are the 4 test points and we're plugging them into our objective function. So first we have 0, 0. I plug that in. 200 times 0 plus 600 times 0 is equal to 0. No surprise, there's our minimum. Coordinate point 2, 0, 30. If we put all of our attention into making tables, we can make 30 tables and no chairs. So we get no money from chairs. And we would get money from 30 tables, which would give us a total of $18,000 in revenue. If instead we devoted all of our resources to making chairs, instead we could make 80 chairs and 0 tables. 200 times 80 plus 600 times 0, we would make $16,000 in revenue. So we can say that, no, it makes more sense to make more tables at the very least. If we were to pick one of them to devote all our attention to, we would make more money only making tables. But finally, what if we sort of had the perfect balance approach and we made the most tables and the most chairs we could make? We could make 50 chairs and 15 tables. So 200 times 50 plus 600 times 15. And this is a total of $19,000 in revenue. Right, of course, this is going to be our maximum, so this is the answer to our question. Right, the only thing that's left to do, step 7, is answer the original question being asked. And that is going to include how many tables, how many chairs, and what that maximum revenue is. Right, so our answer will be the factory should produce 50 chairs and 15 tables for a maximum revenue of $19,000. And then we say, hooray, we're done. Right, that's the end of Math 150. Call it a wrap. Oh, thank you, thank you.